Hello viewers, welcome to another video. In the electrical power system, grounding is one of the most important parameter when it comes to the safety of equipment and the people during the faults. In this video, we will explore the system grounding, which refers to the connection of the neutral point of the generator or the transformer with the earth. So there are multiple techniques of system grounding, but in this video we will explore four most commonly used types of grounding. The first one is the ungrounded system, the second is the solidly grounding, and third is the resistance grounding, which is further divided into two categories, the low resistance grounding and the high resistance grounding. So we will discuss the pros and cons of each type of grounding. So first of all, we have ungrounded system in which there is no intentional connection between the system conductor and the earth. The only link to the ground is through the natural capacitance of all the phases to the ground. So let's discuss the benefit of ungrounded system technique. In this picture, you can see that if the one phase is grounded during the fault, there is no return path of the fault current into the neutral because the neutral is not connected with the earth. The only path in which the fault current flows is through the capacitance of the healthy conductors. So what happens that since the neutral point is not connected to the earth, we have no line to ground fault current. Since we have no fault current, so there is no safety that will operate during the fault and the system will continue to operate during first fall. So we have no immediate tripping. Since there is no fault current, so we have a very less risk of equipment damage. Now let's discuss the cons or the disadvantages of ungrounded system. Since there is no connection of the neutral to the link, so the fault detection is time consuming and difficult. And a second fault occurs on the another phase, it effectively becomes a phase-to-phase fault, which can be very damaging. In this technique, if there is phase-to-earth fault, then the voltages of the healthy phases with respect to the earth rise from the normal phase to the neutral to the full line to line voltages. The last disadvantage is the arcing due to the capacitive current flows into the ground, and if the magnitude is 4 to 5 ampere, then it is sufficient to maintain an arc in the ionized path of the fault. So this current can remain even after the clearance of the fault, and this phenomena of persistent arc is called arcing ground, and this happens only in ungrounded system because there is no link between the neutral and the earth. Now comes the solidly grounding technique, which is the most commonly applied technique. Solidly grounded technique refers to the technique in which the system neutral is directly connected to the ground without intentional impedance. Here you can see a schematic diagram. Here in this diagram, you can see that the neutral of the generator is solidly grounded or connected to the earth. So whenever there is a fault on one phase, what happens? We have two different types of current that will flow from the faulted phase into the ground and from the ground into the neutral. So first current, which is almost negligible, is the capacitive current, and the major current will be the fault current. So the benefit of this technique is it is simple to design and it is low cost because it involves simple connection of neutral to the ground. Because the ground path has low impedance, protective devices can operate rapidly, minimizing the duration of fault detection. It also keeps transient over voltages well under control, and I have explained the phenomena of how the transient over voltages produces during the fault in an ungrounded system. The downside is that since the fault current is very high, which can cause significant equipment damage if not cleared instantly. Also, since the fault current is detected very easily, so the protective devices can trip the system and the whole service is interrupted immediately after the fault. And there is also a higher arc flash hazard compared to the resistance grounding. So third type of the grounding is the low resistance grounding, in which the neutral point of the generator or the transformer is connected to the earth via low resistance, which limits the fault current to 100 to 1000 ampere according to IEEE standard. Now let's discuss the benefit of the low resistance grounding, Here you can see the diagram of a generator in which the neutral is connected to the ground with neutral grounding resistor, and its value is set such that the fault current will remain between 100 to 1000 ampere. So since the fault current is limited, so there is less damage to the equipment. So it also reduces arc flash hazard and have a good control over the transient over voltages that produces during the fault. The fault current is limited. It reduces the stresses on the equipment like breaker and generator itself. So there are certain disadvantages related to this type of technique. It has the higher cost as compared to the solidly grounded technique since it involves a resistor which is costly. Another negative side is that the system will still trip and shut down as soon as the first ground fault happens, so there is no operational continuity. The resistor produces heat during a fault, so it must be sized and ventilated properly. Now comes our last technique, which is high resistance grounding, in which the neutral of the generator or the transformer is connected to the ground with high resistor, which typically limits the fault current to less than 5 ampere. Discuss the benefit of this technique. Since this technique keeps the fault current extremely low, which greatly reduces the flash hazard. Also, it has very effective control over the transient over voltage. And when the first ground fault occurs, the system continues to operate and only triggers an alarm. So there is no immediate shutdown. So there are very few disadvantages associated with this type of technique. It is again costly since it involves a resistor, and the fault cannot be cleared automatically. It has to be located and cleared manually. So I hope you understand these four different types of grounding. For more interesting videos, stay tuned and don't forget to subscribe our channel. Thank you for watching.